Hey students, today's lesson is on subtracting rational numbers. So to start with, let's get this key idea. To subtract rational numbers, we'll use the same rules for signs that we used for integers. And this is really important to know that, here we go. We can always, just like we did with integers, we can change subtraction problems to adding the opposite. And as we get into more complicated numbers with fractions and decimals, that's probably a strategy you're going to want to stick with. We did so much modeling with integers, but it's much more difficult to model when we have more complicated numbers. So we're probably going to stick to the strategy of taking any subtraction problem and changing it to an addition problem of adding the opposite. So let's look at this first example. Here we have negative 4 1/7 minus negative 6/7. So let's first change it to an addition problem. Negative 4 1/7 plus the opposite of negative 6/7, which is positive 6/7. All right, so now we have a negative and a positive. So we're going to need to subtract the absolute values and then take the sign of the larger absolute value. So this is actually a little bit tricky because I can't take 6/7 from 1/7. So sometimes I like to just borrow from the wholes, just like we do when we're subtracting whole numbers, and say this is like negative 3 8/7, because one whole is 7/7. So 8/7 is like 1 1/7. You see how that's the same? Okay, and then plus 6/7. Now when I subtract the absolute values, I have 3 8/7 minus 6/7, which is 3 2/7. And then I have to look back to see whether this is positive or negative. The larger absolute value was the negative rational number, so my sum is negative. Let's go ahead and look at this example where we have decimals. Here we have 12.8 minus 21.6. Let's go ahead and rewrite this as an addition problem. 12.8 plus negative 21.6. All right, so here we have, again, a positive rational number and a negative rational number. We're going to subtract the larger absolute value minus the smaller absolute value. So we're not worrying about which one is positive and which one is negative for now. The larger absolute value is negative 21.6. So we'll do 21.6 minus 12.8. So that's going to be the difference between the two absolute values. Let's see, I can't do 6 minus 8, so I'm going to borrow here. 16 minus 8 is 8. And let's see, I'll just say 20 minus 12 is 8. So the difference between the absolute values is 8.8. Now I need to look back to see if that's positive or negative. The larger absolute value was negative, so this is negative 8.8. All right, so one more key idea here. Oftentimes when we're using subtraction, it's to find the distance between two numbers on a number line. So the distance between any two numbers is the absolute value of the difference of the numbers. So we're going to subtract one number from the other number, doesn't matter which one we subtract from which one, and then we'll take the absolute value. So let's look at an example here. We're going to find the distances between numbers on a number line. 2 1/3 and negative 2 2/3. So I'm going to do it both ways just to show you why we're looking at the absolute value here. So let's start with 2 1/3 minus negative 2 2/3. So I'm going to go ahead and change this to an addition problem. 2 1/3 plus the opposite of negative 2 2/3, which is positive 2 2/3. And then I'm just going to add them together. That's 2 plus 2 is 4, and 1/3 plus 2/3 is 1, so this altogether is 5. But then I want to take the absolute value of this whole thing. So all the way down here, I want to take the absolute value of this and the absolute value of 5 is 5. And we can look at this to see if that makes sense. I see 1, 2, 3, 4 full spaces and a couple partial spaces. So yeah, they seem like they're about 5 spaces apart on the number line. Now I can go the other direction too and subtract negative 2 2/3 minus 2 1/3. I'll take the absolute value of this, and let's see if we get the same thing. Let's change it to an addition problem. So the absolute value of negative 2 2/3 plus the opposite of 2 2/3, which is the opposite of 2 1/3, which is negative 2 1/3. When I add these two negative numbers, I get negative 5, but the absolute value of negative 5 is 5. So we got the same thing either way, depending on which number we subtract from which number. But as long as we take the absolute value, we'll end up with that distance. Because when we're talking about distance, it wouldn't make sense to have a negative distance. All right, so here's a real life application. So we see in the water, the bottom of a boat is 2.1 feet below the surface. And the top of the boat is 8.7 feet above the surface. So I can kind of draw a little picture here of this boat. Make it like a sailboat. And there's the water. And this distance right here from the water to the bottom of the boat is 2.1 feet. And then the distance from the water to the top of the boat is 8.7 feet. Okay, then we've got some information about this trailer too. So let's worry about just the boat first. So if we want to find the height of the boat, we're going to want to add the 2 that's 2.1 feet below. Okay, so actually we'll set this up as a subtraction problem. So we'll say 8.7, that's how tall it is, minus, we'll take the difference, we'll subtract how far it is underneath the surface. And we'll take the absolute value here. Let's change this to an addition problem. 8.7 plus 2.1. We'll take the absolute value of this. So 10.8. And the absolute value of 10.8 is 10.8. So 10.8 feet is how tall the boat is. Then we see that the bottom of the boat is 1.3 feet above the ground if it's pulled on a trailer. So if we put this thing on wheels and put it on a road, that adds some distance here. Okay, so now we need to take our 10.8 feet and add another 1.3 feet. 10.8 plus 1.3. Sorry, I'm getting a little jiggly here. And that would be 11 plus 1.1, that's 12.1 feet. So here this says the clearance is 11.8 feet. So no, I probably should not go under that bridge with that boat. All right, go ahead and try a few on your own, and I will see you soon.